Let's look at the second part of homework 23, where we have to use our standard normal distribution table, also known as the z-table. And it looks something like this. It has front and back with the negative z-scores here down on the left on the first page, and then the positive on the right. Okay, so you need this for each of these problems to look up. So we'll refer to that as needed. So let's get started on looking at the types of problems we have. So first thing you want to notice is that there are three types of problems on this page. We have the ones that are just less than the standard deviation given, right? So that's this column. And then we have some that are greater than, right? And then we have the ones that are between. So there's three types of problems we have to be aware of. Right? And it's important to know this because the table that we're using, and it will remind you here at the top, it only gives our answers to the left, which is less than, right? So we can use this table really easily for the first column just by looking up 1.25. Go to 1.2. So here's 1.2, and then the 1.25 will be 0.89435, right? And it's as simple as that. But when we have the greater than, we'll have to do a little bit more work because this only gives our answers to the left. So at least for the first one here, we have 0.8, make that a little bigger. Yeah, 0.8435. Eight, 9, 4, 3, 5, which if you want to interpret this as an approximation, is about 89.4% of the curve here. In other words, if we find 1.25, okay, let's say right here is 1.25, and we want everything less than, this total area is 89.4% of the total area. See, only this little part here is not shaded in. Okay, if we can do the same thing, I'm going to go down the columns here since these are all similar. Less than negative 0.62. So we'll look up on the negative side, we'll have to go to negative 0.6. Go down. There we go. There's negative 0.6, and to get the O2, this is 0.00, 0.01, and this will be 0.02. And I can follow that up here, the very top, but yeah, see, that's the 0.02 right there. All right, so we have 0.26763. So we have 0.26763, which means this is approximately 26, let's say 0.8% of the whole curve shaded in. And we can show that by finding negative 0.62. Here would be negative 0.5, so 0.62 will be right about here. And yeah, that's definitely about 25, 27% shaded. 3.04 for G, so that's basically, wow, that's everything less than. That's going to be basically, we're going to expect to see a 99.9%. That's basically everything. So if we go to our table and look up the positive side and you go all the way down to 3. Okay, here's 3. This will be 0.0 0, this will be 0.01. So yeah, 0.99869. And as predicted, that's about 99.9%. Right? This is almost the whole entire graph here is shaded to the left. There we go. So now let's look at when it's greater than. So slightly different. All right, greater than 2.17. Right, we want greater than. That's everything over here. So very small amount, right? So we expect to see a very small number for this, 2.17. Okay, let's see here, 2.1. If I get to fit underneath here. 2.1. There we go. And then to get to the 07, see, that'd be 0, 1, 2, 3, 4, 5. So you gotta be careful here. Okay, here is 07. Zero, 1, 2, 3, 4, 5, 6, 7. There we go. So we have 0.98500. But obviously this does not look like 98.5% because this table again only gives us the values to the left. So this 0.98 or 98.5% is all of this. Right, so anytime we have a greater than, we need to do a little setup first. We need to do 1 minus, right, the value of this to the left, right? So I'm going to find that 0.98500, that'll give me all this, and when I subtract from 1, that will give me just this part. Okay, so let's get a calculator out here. And we'll have 1 minus 0.985. That'll give us a very small number, as expected, because this is a very small area. So that means right here is about, if I made this a decimal, 1.5%, right, which seems about right. Now let's practice that. Again, anytime you see the greater than, you automatically want to set it up to be 1 minus. So just get in the habit of doing this every time you see the greater than. Rewrite it this way with the 1 minus. You notice this changes to less than as well, because this is what we can get from the table. We can't get a greater than from the table. Okay, only less than comes from the table. So we'll have 1 minus, and then look up 0.3. Okay, let's look up 0.3. That out of the way. Take these off. Let's see, 0.3. That'd be 0.30. So that's going to be 61791. 61791. Now we need a calculator. 1 minus 0.61791 equals. So we have 0.38209, which is approximately 38.2%. And let's look at the graph just to make sure that makes sense. So we have 0.3, which is right about here. close to 0, and we're doing greater than. So this makes sense that, yeah, this would be a less than 50% right here because it's less than half the graph. So our 38.2% does make sense here. Let's do one more of this type. We have very close to -2, negative 1.98. So our answer here that's greater than this will be a pretty big number, almost 100%. So again, it has the greater than, so we automatically set it up as 1 minus. Right? Because we can only get less than from the table, so we have to write everything as less than and then use the table. So negative 1.98. So I got to find negative 1.9. Where are you? There we are. Negative 1.9. There's negative. And then the 0.8 will be, again, there, right where they meet. So we have 0.02385. 0.02385. There we go. Then we can calculate this. 1 minus 0.02385. We'll have a very high number as expected because it's most of the graph. Remember, the biggest you can get is 100%, right? So 0.97, that's pretty close to 1. That's why it's a big number. And this is approximately, if we round it, 97.6% of the graph, and that does match because most of this graph is going to be filled up. All right, our last type of problem here is the between. So we want to find between two numbers. So just recall from prior sections in this class that this means between. Even though it says less than z, less than, that just means between. So we're trying to find between 0.16. So 0.16 would be right about there, and 1.74, which would be right about here, 1.74. And everything between would be all of this right here. Now the way we do this is, well, if we look up these numbers, remember, it'll give us everything to the left. So if I look up 1.74, it gives me all of this, right? Not just the part I want. And if I look up 0.16, it will give me all of this, right? What you see is that if I just subtract this red part from the blue part that I just went over, it will leave me with the part that I actually want. So that's what we do in order to solve these. We take the blue part and subtract the red part. So the blue part is the 1.74 that I just shaded, and it's everything to the left. So I'm going to find less than 1.74, right? And then I'm going to subtract the red part, right? This part right here, the 0.16 part, I'll subtract that. There we go. And then look up each one of these on the table, then subtract those two decimals. So we're going to get two of these longer decimals now. So let's look up the first, 1.74. Okay, 1.7. There's 1.7, 04 will give me 0.95907. There it is. 0.95907. I already forgot it. Let's see here. One more time. 95907. Okay. And then subtract the 0.16. So find the 0.16. Here's 0.1. Here's the 6. So we have 0.56356. 0.56356. And now I can just subtract those two. So we have point in blue, 0.95907 minus 0.56356. So we got 0.39551. 51, which is about 39.6%. Okay, so about 39.6% just for this area right here. And that does seem to match. So a little bit more work on these in-betweens because we got to look up two numbers from the table, both of course after they're less than here, and then subtract those two numbers. So let's see if we can do this one a little bit cleaner. Oh, one more thing. You'll notice that the big number here is on the left and the smaller is on the right. Right, this ensures that we get an answer that's bigger than 0. If I did this in the wrong order and this came out negative, that would be a problem because that would mean this is negative area, but area cannot be negative. So it's always going to be the bigger minus the smaller. Or if you want to think of it as find the z-score of the last number and subtract it from the first number because the last number here is always going to be bigger. All right, so like here you can see 2.05 is bigger than the negative 2.05. So we're going to find p-value of the positive here, and then subtract the negative. We got to look up the same number, one positive, one negative here. So first the positive here, 2.05. Here's the 2. Here's the 0.5. So those are going to converge right here at, it's like 0.97982. So we have 0.97982. And we're going to subtract the negative. Let's see here. Negative. So let's go on the other side. Negative 2.05. Those converge at 0.02018. 0.02018. And then let's go ahead and subtract those two. And we get 9.95964, which is a pretty big number, right? It's almost 1. This is 95, well, 95, actually 96% if we round it. That's most of the graph, right? So let's check that. Negative, going to be between these two numbers, right? Negative 2 is right here, positive 2 is right here, and then everything between. Yeah, that's most of the graph. So it does seem likely it's 96%. Okay, lastly, let's do the graph first here. We have negative 1.54, so here's negative 1.5, so that's going to be good enough to estimate. And here we have 5.53, so that's about half. 0.5 is right about here. So we're going to look at everything in between these two. So a fairly big number, but not too big, right? Most of this is empty on this side, at least. So remember, we want to find the value of the bigger number, 0.53, and subtract the smaller. Okay, table time. Let's go 0.53. It's going to be on the other side where the positives are, 0.5. Here's 0.5, and here is 0.3, so 0.53 would be 0.70194. Right, and then minus, we need to look up negative 1.54. Okay, so I'll be on the other side. Negative 1.50123.4, that should be right there. Double check that. Yes. So we have make that bigger. 0.06178. Okay, there we go. And use a calculator. 0.7D194 minus 0.06178. We'll have 0.64016. Okay, which is about 64%. Right, so that looks about right. This is about 64% shaded, right? Pretty close to 50, but above for sure. Okay, so that's the conclusion of how to look up z-scores on a table, and we have 3 different types. Again, we have the less than, which is you just look at the table directly, and that's your answer. We have the greater than, which we have to subtract from 1 because the table only gives us to the left. So to find the other side, we subtract from 1. And then we have the between, where we always have to subtract the bigger minus the smaller number, or the right number minus the left number when you look at it on the table. Okay, I hope that helps, and see you next time.